binti Jaafar, matrix 11 DKA 18F2001.
My name is Nur Amira binti Ramlan. My matric number is 11 EKA 18F 2002.
Hi, Assalamualaikum. My name is Ratu Husna binti Ahmad Mustafa, matrix number 11 DKA 18F2003.
My name is Siti Hajar binti Muhammad Noh, matric number 11 DKA 18F224. Objective: to study the mechanical properties of male sterile specimen under tension load. Step 1. Measure the initial diameter of tension. Test sample in two particular directions using vernier clipper. Step 2. Measure the length of the specimen between the grip using a scale. Step 3. Push marks are made at a distance of 2.5 diameter. Step 4. Insert the specimen into its position and mount in tensiometer on the specimen.
5. Reading on the dials A and B of extensometer are adjusted to 0. Experiment is conducted. Load extensometer readings are read at regular interval of load up to the yield point. Ivory scale readings are noted till the specimen failure. Number 7. Join two pieces of test sample and measure the diameter at the neck of the specimen. Measure the final length between three punch marks. Yield stress 335.65 Newton per millimeter square. Tensile strength 416.53 Newton per millimeter square. Modulus of elasticity 211 GPa. Percentage elongation 29.91%. Percentage reduction in area 64.28%.
After I gone through the basic theory and the procedure to use the simulator, I will answer the question in self-evaluation to check my understanding. So let's start. Question 1. Yield point is the main point on stress or strain graph where plastic deformation commences. Next, what is the distance between the punch marks in the experiment? The answer is 2.5 D. Question 3. While conducting the experiment, the mode of fracture observed in mild steel specimen is cup and cone shape. 4. Elastic deformation of the material is associated with. ductility of the material. Question 5. The law which influences the material up to yield point is Hooke's law. My score is 5/5.
Question number 1. Draw the stress-strain diagram for a ductile and brittle material and what is the difference in it? So, it is a diagram of ductile material and brittle material.
Difference between ductile material and brittle material. The first one is percentage elongation of the ductile materials before fracture under tensile testing is higher, while the percentage elongation of brittle materials before fracture under tensile testing is very less. Next, ductile materials fail gradually by neck formation under the action of external tensile loading. Brittle materials fail by sudden fracture without any warning, such as necking. And energy absorbed by ductile materials before fracture under tensile testing is more, while brittle materials absorb very small energy before fracture. Next question. What do you understand by strain hardening? Strain hardening, also called work hardening or cold working, is the process of making a metal harder and stronger through plastic deformation. When a metal is plastically deformed, dislocation move and additional dislocations are generated. The more dislocation within a material, the more they will interact and become pin or tangle. This will result in a decrease in the mobility of the dislocations and a strengthening of the material. This type of strengthening is commonly called cold working. Strain hardening can be easily demonstrated with a piece of wire or a paper clip. Bend a straight section back and forth several times. Notice that it is more difficult to bend the metal at the same place. Question 3. What do you mean by percentage reduction in area? Reduction of area is the proportional reduction of the cross-sectional area of a tensile test piece at the plane of fracture measured after fracture. Reduction of area is reported as additional information to the percent elongation on the deformational characteristic of the material. The two are used as indicators of ductility, the ability of a material to be elongated in tension. Because the elongation is not uniform over the entire gauge length and is greatest at the center of the neck, the percent elongation is not an absolute measure of ductility. Reduction of area being measured at the minimum diameter of the neck is a better indicator of ductility.
Explain the step in ductile fracture. So the answer is step in ductile fracture are void formation, void coalescence, also known as crack formation, crack propagation, and failure of the resulting inner cup and cone-shaped failure surface. Void typically coalesces around precipitated secondary repaste inclusion and grain boundaries in the material. Ductile fracture is typically transgranular and deformation due a dislocation slip can cause the shear lip characteristic of cup and cone fracture. Explain the modes of failure in tension tests. So the answer is all tension tests show an elastic behavior until breathing failure occurs, which is typically behavior of FRP composite with unidirectional fiber. Point number 2. A part failure mode is the way in which a component fails functionally on the component level. Often a part has only a few failure modes. For example, a relay may fail to open or close contact on demand. Point number 3. Failure codes are defects in design, process, quality, a part of application, which are the underlying cause of a failure or which is a process which leads to failure. Number 1. All work done on the specimen is stored in form of strain energy. Number 2. Part of energy is wasted in form of heat and sound. So the answer is elastic stage and plastic stage. So the answer is 2. B. Number 2. Tensile stress measured in, so the answer is Pascal. Number 3. Significant neckling was found to occur in a tensile test piece. Examine the areas indicated on strain or stress curve and indicate where neckling or specimen has occurred. So the answer is D2E. Number 4. Following statement in relation to Young's modulus are correct with exception of. So the answer is it measure of resistance to plastic deformation. Last question is, which mechanical property of the material is indicated by the total area under a stress strain curve? So the answer is tautness.